let us understand what a force can do. A force can set a stationary object into motion. It can be pushing an object, or pulling an object, or kicking a football, etc. A force can stop an object which is in motion. A force can also change the direction of motion of an object. A force can cause deformation to the body on which it is acting. We have discussed what a force can do. Now we can define a force as it is an action exerted on an object which tend to change or change its state of rest or motion. The SI unit of a force is Newton, where 1 kilogram equal to 9.81 Newton, which can be approximated as 10 Newton. And SI stands for International System of Units, which is followed by all the countries around the world. Now let us discuss about the characteristics of a force. Let us say that there is a box which needs to be moved to this particular location. If I am told that it requires 10 Newton force to push the object, still the information is not complete. I also need to be told about the specific location where it needs to be placed so that I can push it in that particular direction. So, force is a vector quantity which is specified by both magnitude and direction. The second characteristic is the point of application of the force. To push this particular box, I can apply the force at this particular height. But if I apply the force at a greater height, the box may actually tilt and tip over. Now let us discuss about the different types of forces. This is not a generic classification related to the broader scope of physics. For example, we have magnetic forces, electrostatic forces, muscular forces, etc. based on contact and non-contact forces, which are not related to our subject. This classification of types of forces is specifically related to the rigid body mechanics, and we will discuss them one by one. Now let there be XYZ axis spanning in 3 directions. This is the XY plane, this is the YZ plane, and this is the XZ plane. First one, if the forces are originating from the same point, or if they have same point of origin, then they are called as concurrent forces. Here, the common point of origin is A. Next, non-concurrent forces. If the forces do not have a common point of origin, then they are called as non-concurrent forces. They can also be called as parallel forces. Next, coplanar forces. If the forces exist in the same plane of axis, then they are called as coplanar forces. Here we have two forces F1 and F2 both existing in the same XY plane. Next, non-coplanar forces. Here force F1 is in XY plane and force F2 is in YZ plane. So if the forces are existing in different planes, they are called as non-coplanar forces. Next, coplanar and concurrent forces. If the forces have same point of origin, they are concurrent forces. And if such forces exist in the same plane, they are called as coplanar and concurrent forces. Here we have concurrent forces F1, F2 and F3 existing in the same XY plane. Next, coplanar and non-concurrent forces. If the non-concurrent forces exist in the same plane, then they are called as coplanar non-concurrent forces. Here we have forces F1 and F2 which are non-concurrent but existing in the same XY plane. Next, non-coplanar and concurrent forces. Here we have one force F1 in XY plane and another force F2 in XZ plane. Both are concurrent but are situated in different planes. They are called non-coplanar and concurrent forces. Next, non-coplanar and non-concurrent forces. Here we have force F1 in XY plane and force F2 in XZ plane. They are non-concurrent and are situated in different planes. They are called non-coplanar and non-concurrent forces. Next, collinear forces. In a given plane, if the forces have same line of action, then they are called collinear forces. They can be either along the same direction or acting opposite to each other. Next, normal force or reaction force. Let there be a box resting on a rough horizontal surface. The weight of the box acts downwards perpendicular to the surface as a gravitational force pulls it in the downward direction. And as a consequence, the surface offers an equal and opposite reaction. The weight of the object can be called as an action force and the normal force offered by the surface is called as a reaction force. Next, friction force. Let's say we apply a horizontal external force on the object. The body tends to move, but if the applied force is not sufficient, the body does not move because of the friction force which acts in the opposite direction of the tending direction of motion. This frictional force exists between the object and the surface, which are rough in nature. Next, balanced forces. We can observe here that the action force is balanced by an equal and opposite reaction force. So we can say that the forces are balanced in vertical direction, and they can be called as balanced forces. Also, the applied force is balanced by equal and opposite friction force. Therefore, the forces are balanced along horizontal direction also. They are also called as balanced forces. Now the whole system is at rest. We can call this condition as static or equilibrium condition. So, when the forces are balanced in all directions, then we have equilibrium condition. Next, unbalanced forces. When the action force is equal to normal reaction, they are called as balanced forces. And in that case, the net force or the resultant force will be equal to 0 along the vertical direction. But suppose if the applied force is greater than the opposing friction force, then they are called unbalanced forces. And there exists the resultant force which is equal to the difference of applied force minus friction force. This resultant force or the net force causes motion to the object in horizontal direction. Next, couples. Couples are a set of equal, parallel and opposite forces separated by a distance d. The effect of a couple is that it produces rotation or torque, which we call it as moment. The magnitude of the moment is equal to the product of magnitude of one of the forces and the perpendicular distance between them. The couples can make clockwise or anti-clockwise moment based on the directions of the forces. If the forces are directed this way, they will make a clockwise moment. And if the forces are directed this way, then they will make an anti-clockwise moment. These different types of forces exist in different situations, but we can take a practical example of a truss bridge where we can find most of the types of forces. If we go closer to the bridge, we can see that there are so many members in the truss spanning in different directions in a three-dimensional plane. Some are inclined, some are horizontal, and some are vertical. Now let us zoom to this position of the bridge near one of its abutments. Let us consider this joint. These are some of the forces in the members which are concurrent, right? If we consider these three forces in the members, they are non-concurrent, and they can also be called as parallel forces. On top of that, they are also existing in the same plane, so we can also call them as coplanar forces. Now let us focus here. Consider these three set of forces on this frame which lie on this plane, and these three set of forces which lie on the other plane. The two set of forces are parallel to each other and lie on different planes, so they are non-coplanar and also non-concurrent. Now let us come to this side. Consider a joint here. These are the three forces in the members connected at this joint which lie in a horizontal plane. Here is another force in the member connected to the same joint but lie in a vertical plane. So they are non-coplanar but concurrent forces. Coming back to this side again. Considering this long member at this joint, these are the two forces which lie along the same line of action. Hence they are collinear forces. So that's all in this video. Thanks for watching. Have a nice day.